Okay, so we shall continue with our lesson. This video is now all about the indefinite integral of the transcendental functions. We've known already the transcendental functions. We have logarithmic functions, just like here. We have exponential functions. So first off, we will be dealing with the integrals of the logarithmic functions. Now, for the formula, if we have the integral of a du whole over with a u, then that is automatically equivalent to the ln of u plus c. Okay? So basically, if we see a fraction and if we are going to evaluate the denominator, deriving the denominator, the numerator is the direct derivative of the denominator, then automatically that is equivalent to ln u plus c. Okay. So furthermore, in our previous discussions, in the previous videos, we have this formula for the power rule, the integral of u raised to the power of n du. That is equivalent to u raised to the power of n plus 1 whole over with n plus 1 plus c for the power rule, given the situation that our n, our power right here, should not be equivalent to negative 1. Okay. Why? What would happen if the value of our exponent right here, n, is equivalent to negative 1? It will be this formula, ln u. So notice here, integral of du over u, if we try to take the inverse of u, du over u, if we try to take the inverse of u, that is u raised to the power of negative 1 du. When our n is equivalent to negative 1, this is our n. When our n is now equivalent to negative 1, ln u plus c. Given to which that the value of our n, the value of our exponent, is equivalent to negative 1. So integral of du over u, that is equivalent to ln of u plus c. So we have to check the relationship of the numerator and denominator. So deriving the denominator, hoping that the numerator is equivalent to the derivative of the denominator, so that we could use this formula, ln of u plus c. Okay, for example number 1. So the topic is all about the integrals of the logarithmic functions. So our fraction. Now we will try to test or try to check if the numerator is the derivative of the denominator. So we will try to derive. So we have to assign the denominator as the u. We have x cubed plus 1. Let's derive the u, the derivative of u. The derivative of x cubed plus 1. We have the derivative of x cubed, 3x squared, the derivative of x, which is dx. The derivative of 1 is 0. Okay, so let's try to check the numerator. So for the numerator, we have x squared dx. So the du should be 3x squared dx. We have the dx, we have the x squared. So we're lacking with 3. So we will be correcting this one with 3 over 3 integral of x squared dx whole over with x cubed plus 1. We will take the numerator side of the 3 over 3. So what's left outside is 1/3 integral of 3 x squared dx whole over with x cubed plus 1. So notice we can substitute that for the denominator we have the u, x cubed plus 1. For the numerator we have the du, which is 3x squared. 1/3 integral of du over u. So integrating du over u, that is equivalent to ln of u plus c. So you have 1/3 ln of u plus c. What is the value of the u? So we will bring back, substitute back the value of the u. So for the final answer, we have 1/3 ln of the u is x cubed plus 1 plus c. So this is our final answer. Okay, let's evaluate the integral of x squared plus 2 over x plus 1 dx. Okay, so the very first thing that we need to do is again assign what is our u and what will be our du. That's what we've learned from the previous videos. But apparently, if you try to check the fraction that what we have, that is an improper fraction. So as you can see, we have x squared plus 2 as the numerator and the denominator is x plus 1. If you will assign x plus 1 or the denominator as the u, x plus 1, and if you will try to derive this one, the derivative of x is dx. If you look at the numerator side, if you've assigned this one as the u, this one as the du, what's the purpose of x squared plus 2? Okay, so you cannot directly find relationship between the numerator and denominator. So what shall we do is that we will try to check first the fraction. Okay, fraction right here is improper fraction. So we will try to do algebra for this one first. So this is the wrong assignment. We will have to divide this one first, the long method. So we have x squared plus 0 for the value of x plus 2, and we have x plus 1. Okay, to achieve x squared, we will multiply x with x, we have x squared, x times 1, we have x. Subtract, we have 0, so we have negative x plus 2. So we now have x. To eliminate negative x, so we will multiply minus 1, so that we have negative x minus 1. Okay, proceed with subtraction. We can cancel x, and we have 2 plus 1, which is 3. So we do have a remainder of 3 all over with the divisor, x plus 1. So the equivalent form of the integral of x squared plus 2 over x plus 1 could be replaced with this one. Now we could have x minus 1 plus 3 over x plus 1, and we have the dx. Okay, so notice we could distribute the integral symbol and the dx to all our terms right here. Integral of x dx minus integral of dx plus integral of 3 over x plus 1 dx. We could factor out 3. Integral of dx plus 3 integral of dx over x plus 1. Okay. This one is power rule. This one is general rule. How about this one? Okay, for this one, obviously there is now a relationship between the numerator and denominator. So if we try to assume the denominator is equivalent to u, x plus 1, and the derivative of u, that is dx. Okay, so this is du over u. X dx minus integral of dx plus 3 integral of du over u. Okay, integral of x dx, power rule, x 1 plus 1 over 1 plus 1 minus integral of dx is x plus 3 integral of du over u, that is ln of u. This is ln of u plus c. Okay, we have x squared over 2 minus x plus 3 ln. What is our u? So our u is declared right here. U is x plus 1. Quantity x plus 1 plus c. This will be our final answer. Okay, so this is the process. For number 3, let's try evaluating the integral of secant theta tangent theta d theta whole over with 2 secant theta plus 3. Okay, so in this topic, we will try to again find the relationship between the numerator and denominator. So we will be assigning values of the u, and let's try to check if the numerator it is the du. So for the u, we have 2 secant theta plus 3, the derivative of the u. Constant multiple rule, copy 2, the derivative of secant theta, that is secant theta tangent theta, and then the derivative of theta, which is d theta. The derivative of 3 is 0. The derivative of constant is 0. We will be correcting this one again. 2 over 2 integral of secant theta tangent theta d theta all over with 2 secant theta plus 3. Okay, so we can write 2 inside. So this is now obviously a du over u. So trying to integrate 1/2 ln of u plus c. What is the u? It has already been declared. That is equivalent to 2 secant theta plus 3 plus c. This will be our final answer. Okay. Number 4. The integral of cosecant theta cotangent theta d theta whole over with 1 minus cosecant theta. Again, for this topic, we will be first checking out the relationship between the numerator and denominator. So if we assign u as 1 minus cosecant theta, the denominator, let's hope that the numerator is the direct derivative of this one. The derivative of 1 is 0. Negative, the derivative of cosecant, that is negative cosecant theta cotangent theta d theta. Okay, negative times negative, we have positive. And if you try to check, okay, very good, we have the direct derivative of the u. So this is now du all over with u. The integral of du over u, that is ln of u plus c. What is the u? The u is 1 minus cosecant theta plus c. Okay. Number 5, we have the integral of secant squared x tangent x dx whole over with 4 plus tangent squared x. Okay, let's evaluate number 5. So assigning the denominator as the u as 4 plus tangent squared x. What is the derivative of our u? The derivative of 4 is 0. So The derivative of tangent squared, power rule, we bring 2 forward. 2 tangent x. The derivative of tangent x, that is secant squared x. The derivative of x, which is dx. Okay, the chain rule. Tangent squared. So 2 tangent theta or tangent x. The derivative of tangent, which is secant squared x dx. Okay, so let's try to check in our original integrand. So we have secant squared, we have dx, we have tangent, we need to put 2 here. Okay, so we will correct this one with 2 over 2 again. Integral of secant squared x tangent x dx whole over with 4 plus tangent squared x. Notice we could again write 2 inside our integral symbol 2, and we have 1. Okay, notice we now have 1/2 integral of the du whole over with the u. So the integral of d over u, that is again with ln of u plus c. We now have 1/2 ln of, what is the u? The u is 4 plus tangent squared x, and of course plus c. Our final answer. Okay. Now for number 6, the integral of x squared minus x over x plus 1 dx. We are already oriented that the first thing that we will do is try to find the value of the u, or try to assign the value of the u. If we directly use the denominator as the u with x plus 1 and the du, the derivative of x, which is dx, the derivative of 1, which is 0. Now notice for our numerator side, we only have dx, and what's the purpose of x squared minus x? So apparently we don't have relationship between our numerator and denominator for us to use the logarithmic integrals. So first, let's try to check the numerator and denominator values. So for this fraction, if we will try to evaluate x squared minus x over x plus 1, notice this is again an improper fraction. So we have to divide this one first with the long method for us to solve the problem. So we now have first our x squared minus x, and we have the constant 0. Okay, with x plus 1. So to eliminate x squared, let's multiply with x squared plus x. Subtract, cancel. We have negative 2x plus 0. To eliminate negative 2x, we'll multiply minus 2. So we now have negative 2x minus 2. Subtract. We'll be canceling this one out, and we have positive 2. We have a remainder of 2 over x plus 1. So we will try to replace our original function or original equation with quantity x minus 2 plus 2 over x plus 1 dx. Okay, distributing our integral symbol in the dx to all our terms. Integral of x dx minus integral of 2 dx plus integral of 2 over x plus 1 dx. Again with the power rule and simple general rule. This one we will assign you This time, we will be confident in assigning the denominator as the u, x plus 1. The derivative of the u, which is dx. 2 is just a constant. We could write that one outside the integral symbol. So we now have integral of x dx minus, let's write 2 first, integral of dx plus 2 integral of, that is obviously now equivalent to the du over the u. Take the integral. So x raised to the power of 1 plus 1, we have 2 over 2 minus 2x plus 2 ln of u plus c. So we now have x squared over 2 minus 2x plus 2 ln, what is our u? We have x plus 1 plus c. Okay, so this is now our final answer. The moment that no matter what we do, no matter what assignment for the u and du will be, and if you don't get any relationship between numerator and denominator, try to check first the value of your fraction. If it is improper, you can use long division. Okay, now for number 7, let's have the integral of x squared minus 2 whole over with x cubed minus 6x plus 2 dx. Okay, let's try to check the relationship between the numerator and denominator. So for the denominator, let's choose this one as our u, x cubed minus 6x plus 2. What will be the derivative? The derivative of x cubed, which is 3x squared dx, minus the derivative of 6x, which is 6dx. Let's try to figure out the dx. We have 3x squared minus 6 dx. Checking at our original integrand, we have dx. We have x squared minus 2, but here we have 3 for the x squared and 6. So to make this one as 6, we will multiply 3. To make this one as 3x squared, we will multiply 3. So we need to correct by multiplying 3 over 3. So we now have x squared minus 2 dx all over with x cubed minus 6x plus 2. We'll be using the numerator 3. So this will now become 3x squared, and this will now become 6. Okay, so now have 1/3 integral of, this one it's the du, and this one it's the u. So 1/3 ln of u plus c. What is our u? So now have final answer 1/3 ln of x cubed minus 6x plus 2 plus c. That will be our final answer. Now for number 8, if you look at the problem and you would directly use the denominator as the u, you would notice that the derivative of the u is dx here, present here. You would notice that we have a problem because we have x cubed. This one needs to be simplified first, because as you can see, our fraction, it is an improper fraction. So we'll use long division first in order to evaluate this one. Let's have x cubed plus 0 for the x squared plus 0 for the x plus 0 for the constant. And let's have x minus 1. Okay, so to eliminate x cubed, let's multiply x squared. We have x cubed minus x squared. Subtract. We could cancel x cubed. We now have positive x squared, bring down 0. To eliminate x squared, so let's multiply with x x times x, we have x squared minus x, subtract, we could cancel this one, we have a result of positive x, bring down 0, and to eliminate x, we will be needing 1 plus 1, we now have x minus 1, subtract, we would cancel this one, and we have no result of 1. A remainder of 1 whole over with x minus 1. So meaning to say we will be replacing the original fraction with this proper fraction. We now have the integral of x squared plus x plus 1 plus 1 over x minus 1 dx. Distributing the integral symbol in our dx to each of our term, we now have x squared dx plus integral of x dx plus integral of dx plus integral of dx over x minus 1. Notice that the last integral is part of the logarithmic. If we assign the denominator as x minus 1, what is the derivative of the denominator, which is dx? Okay, right here. This one, it's the power rule and the general theorem. Okay. So let's evaluate this one. X squared, that is x cubed over 3. X is x squared over 2. Dx is x plus, this one is du over u. The integral of du over u, that is ln of u, which is x minus 1 plus c. This will be our final answer. Now the next transcendental function that we will be evaluating are the exponential functions. So we have two formulas here at the integrals of exponential functions. We have the integral of e to the u du. So part of the transcendental function. We have also the integral of a to the u du. Where did we get this formula? This is basically from the derivative formulas. So the derivative of the transcendental function, the derivative of e to the u, and we have the derivative of a to the u. So the derivative of e to the u, copy e to the u du, and we have the derivative of a to the u, that is a to the u ln of a, and we have the derivative of u. So taking the integral of this side, we have now the formulas. Okay, we have the two formulas. Integral of e to the u du, we have e to the u plus c. A to the u du, not all the time that we have ln of a here. So this is a constant. So if we divide both sides with ln of a, all over with ln of a. So integral of a to the u du, that is a to the u over ln of a plus c. The conditions should be a could be any real number except -1. Okay, let's start answering. Okay. The integral of e raised to the power of x over square root of x dx. We will be assigning the u. Now from our previous formula, notice that u is obvious, the exponent of e. So if we set, or if we assign u as the square root of x, the du is 1 over 2 square root of x dx. We already have dx, we already have square root of x on the denominator, we only need 2 for the denominator. So if we correct this one with 2 over 2, integral of e raised to the power of square root of x, 1 over square root of x dx. If we place the denominator 2 here, so this is now the form of e to the u du. Okay? So 2 integral of e to the u du, that is e to the u plus c. What is the u? That is obviously square root of x plus c. This will be our final answer. If we have e raised to the power of 2 minus 5x dx. Now again, our u is very obvious. It is the exponent of our e. U is 2 minus 5x. The derivative of u, 2 is 0, negative 5 dx. We already have dx here. We only need negative 5. So we need to correct this one with multiplying negative 5 over negative 5 integral of e raised to the power of 2 minus 5x dx. Writing negative 5 inside and placing 1 here. We now have the form 1/5 integral of e to the u du. Okay, integral of e to the u du, negative 1/5 e to the u plus c. Negative 1/5, bring back what is the original value of u, 2 minus 5x plus c. This will be our final answer. Now for examples 1 and 2, the value of the u is very obvious. Now for example number 3, we have the integral of 1 plus e raised to the power of 2x all over with e raised to the power of x dx. So this is far different from the previous two example. Why? Because it is very obvious. In the previous example, the value of the u is very obvious. We only need to derive that one in order for us to evaluate. But this time, we have two different value of the e and two different exponents. We have x and 2x. So we will do algebra for this one first. So notice, if we try to set the denominator as the u, the du is e raised to the power of x dx. We would do an algebraic process. Okay? So what is our algebraic process? We could either separate the denominator or we could take the inverse. So taking the inverse, 1 plus e raised to the power of 2x. Taking the inverse of our denominator, this will become e raised to the power of negative x dx. Okay, so we will try to distribute this one to our term right here. We have e raised to the power of negative x plus e raised to the power of x dx. Distributing to all our terms, we now have e raised to the power of negative x dx plus integral of e raised to the power of x dx. Notice that we now have two different integrals. We could assign u's and du right here. So the u here is negative x, the du must be negative dx. The u here is x, the du here will be dx. This is now good for integration. How about this one? We need negative. So if we place negative outside, and we would also place negative inside. This is now negative integral of e to the u. It's du plus integral of e to the u du. Integral of e to the u du, negative e to the u plus e to the u plus c. What are the u here? The u here is negative x and the u here is positive x. So our final answer will become negative e to the power of negative x plus e raised to the power of x plus c. Our final answer. Okay. If we have the integral of e raised to the power of 3x whole over with 1 minus 2 e raised to the power of 3x squared dx. Now notice there could be a relationship between numerator and denominator, unlike with example number 3. Here you have noticed that we have the same degree, or we have the same value of the exponent, e raised to the power of 3x, e raised to the power of 3x. If we assign the denominator as u, or this quantity as u, 1 minus 2 e raised to the power of 3x, the derivative of that, the derivative of 1 is 0, minus 2 times 3, we have 6 e raised to the power of 3x, and the derivative of x, which is dx. If you have noticed, we have dx right here, we have e raised to the power of 3x, we only lacks the value of 6, negative 6. So we will be correcting this one, negative 6 over negative 6, integral of e raised to the power of 3x dx, all over with 1 minus 2 e raised to the power of 3x squared. So writing negative 6 inside and placing 1 right here, we now have 1 6. Integral of this one is obviously a du, and the denominator is u raised to the power of 2. Now, since we have 2 here, we'll be applying power rule. Negative 1 over 6. This will now become u raised to the power of negative 2 du. Applying power rule, negative 2 plus 1, that is negative 1. Negative 1 over 6. U raised to the power of negative 1 over negative 1. And our plus c, of course. Negative 1 over 6 times negative 1, that is positive 1 over 6. And to have a positive exponent in our u, take the inverse. So this is whole over with u plus c. So our final answer will be 1 over 6. What is the u? 1 minus 2 e raised to the power of 3x plus c. Now this is our final answer. Okay? Now we have two different examples for the topic exponential functions. So integrating exponential functions is not the same with our previous two examples. Why? Because it is directly integrable. Well, this one you have to do algebra first, and this one is basically the first topic that what we have discussed already, the power rule, the application of the power rule. Number 5, we have the integral of the square root of 10 raised to the power of 3x dx. Okay, so evaluating number 5 first, we will rewrite the square root of 10. So we have 10 raised to the power of 3x raised to the power of 1/2 dx. In algebra, if we have a raised to the power of n raised to m, that is equivalent to a raised to n times m. So if we have this one, 10 raised to the power of 3x raised to 1/2, so this is also equivalent to 3x over 2 dx. Or we could write as 3/2. Okay. Integral of a to the u du, that is a to the u ln of a plus c. So we will be identifying the u. So it is obvious, the u is 3 over 2x. The du is 3 over 2 dx. So we need 3 over 2, correcting, dividing, multiplying with 3 over 2 whole over with 3 over 2, that is 1. Integral of 10 raised to the power of 3 over 2x dx. Writing the numerator 3 over 2. So this will be now become 1. 1 whole over with 3 over 2. That is equivalent to 2/3. Integral of a to the u. This is our u and this is the du. Integral of a to the u du, that is a to the u over ln of a plus c. So we have 2/3 a to the u whole over with ln of a plus c. Okay? Now placing back the values of a and u, we have 2. What is our a? 10 raised to the power of 3 halves x whole over with 3 ln of 10 plus c. Now this will be our final answer. So we could put multiplication symbol right there. Now solving number 6, we have integral of 3 raised to the power of 2x dx. The u is very obvious, 2x. A raised to the power of 2x. The du, it's 2 dx. We already have dx, we need to supply this one with 2. So correcting, 2 over 2, integral of 3, 2x dx. Writing the numerator 2 inside. This will now become 1. We now have 1/2 integral of a to the u, and this one is the whole du. Integral of a to the u du. This is now 1/2 a u over ln of a plus c. Or we could have a, what is a? It's 3. The u is 2x whole over with 2 ln of 3 plus c. Our final answer. Now for number 3, the integral of a raised to the power of nx dx. A raised to the power of nx dx. Assume that n here is our constant. So the u is nx, the derivative of u is n dx. We need n, so correcting this one, n over n, integral of a raised to the power of nx dx. Writing n inside. Now this is now the form L1 over n, integral of a to the u du. 1 over n, a to the u over ln of a plus c. We have a, the u is nx whole over with n ln of a plus c. This is actually number 7. Now, number 8. Okay, so number 8, if we have the integral of 5 raised to the power of x to the 4th plus 2x quantity 2x cubed plus 1. Okay, so we will try to assume again this one as the value for the u. X to the 4th plus 2x, the derivative of the u. We have 4x cubed dx plus 2 dx. Factoring out dx, 2x cubed plus 2 dx. If we are going to check our original integrand, we have dx, we have 2x cubed plus 1, so dividing this one with 2, dividing then this one with 2, we have this one. So we need to multiply this one with 2. So correcting, 2 over 2, integral of 5x to the power of 4 plus 2x. And we have right here 2x cubed plus 1 dx. Writing 2 inside. Distributing 2. 2 times 2, this will now become 4. 2 times 1, this will now become 2. This is now the form of a to the u, and this is the whole du. So you now have 1/2 a to the u over ln of a plus c. Or we have a to the u. What is our a? 5. The u is x to the power of 4 plus 2x whole over with 2 ln of 5 plus c. This will be our final answer.